Okay, so in the final step, which is step 3, we need to understand what is the confluence of rewrite rules. Okay, so eventually all proofs will become rewrite proofs. Okay, but given a theorem for our case's equation, is the set of rewrite rules enough to generate a rewrite proof for it? Or do we need to add more rewrite rules? Will this way of adding rewrite rules ever terminate? Which means, is the complete set of rewrite rules ever be finite? Okay, so we'll introduce the idea of confluence for any set of rewrite rules to discuss these questions. So let us see, what do I mean by confluence set or locally confluent set. So for locally confluent set, if all critical pairs have rewrite proofs, okay, so remember when we do superposition, we will generate a critical pair. So whenever it branch out, okay, for the critical term, it branch out to two critical a critical pair, and the critical pair have rewrite proofs, okay, and no new rules need to be produced. We call this set of rewrite rules locally confluent. Whereas confluent, which is a more general case, is if whenever a term, okay, need not be critical term, any term, okay, can be rewritten into two different forms. Okay, by the way, the arrow over here, there's a star here, means transitive and closure, reflexive closure. This means that for this case, if the arrow without the star means that it's gonna like reduce in one step. Okay, just a reduction in one step. But this case is reduction of 0 or more steps. Okay, so it can be even more like 3, 4, R1, R10, R a lot, just to hit here. Okay, you get into 2. Okay, so confluence means every term can be rewritten into two different, whenever a term can be rewritten into different forms, T1 and T2, the T1 and T2 will have a rewrite proof itself. Okay, so why is it so important that initially we state that we need the rewrite rule to be Noetherian? Because in Noetherian rewrite rule, okay, for Noetherian rewrite system, which means if the rewrite rules are Noetherians, okay, these two concepts, locally confluent and confluent, are equivalent. So instead of, for this is much more of the more general term, because for every term they can be rewritten into two different terms in 1, 0 or more reduction law for each one of them, rules for each one of them. Then we need it to have a rewrite proof. For this is, as long as when we get a superposition, we get a critical pair, as long as each one of them, each critical pair that we generate, every critical pair are able to get the rewrite proofs, then it's done. So this is much simpler to satisfy as compared to this one, where we need to check term by term. For this one, all you need to check is all the superposition, all the critical pairs, make sure they have rewrite rules. Okay, so yes, because of this Noetherian rewrite system, these two concepts are equivalent. Okay, so in the main paper, okay, we state that the critical pairs lemma. So to test for local confluence, it is sufficient to consider only those critical terms found by superposition of the left-hand sides of the rewrite rules at non-variable occurrence. Okay, so what we have did previously by superposition of the left-hand side of the rewrite rules, okay, we just need to consider all the rewrite rules and superposition of the left-hand side of it. Okay, we don't need to look at each one of the term and see whether each of the term whether will eventually go into two different terms, then see whether for each different pairs of term then will have a rewrite proof. All we need to do is superposition of all the left-hand side of the rewrite rules and make sure that there will be rewrite proof for each pair of each critical pair that we have superposed. So canonical set of rewrite rules. So what is this? A Noetherian and confluent set. Okay, this means that every term has a unique normal form. Okay, so we call it a canonical representation. So with that being said, after having a unique normal form, any two terms T1 and T2 are equal, okay, if and only if T1 and T2 have a rewrite proof, which means both will normalize to a same normal form, and that normal form will be unique, and do not need to scare whether it might be different. But for this case, if you have a canonical set of rules, okay, they will have the unique normal form if they have a rewrite proof for the two terms. So as a result, okay, canonical set of rules provides a decision procedure for reasoning in an equational theory, as I mentioned. Okay, so validity of any theorem T1 and T2 can be tested by reducing T1 and T2 their canonical form, which are the normal form. So same normal form imply that the theorem is true, otherwise it's false.